Project 5, Coal-Fired Power Plants by Michael Hawks. How coal-fired power plants work. First, the coal is processed into a very fine powder, and then it's burned to heat purified water. The water is heated to a very high temperature where it turns to steam. This creates very high pressure of up to 3,500 psi. As the process continues, the steam drives a turbine, which in turn drives generators. These generators produce electricity. The steam is condensed and reused in the process. An example of a coal-fired power plant in Colorado is the Hayden Generating Station. This station produces 446 megawatts of power annually. The method it uses to do this is a steam turbine, and the fuel source is low-sulfur coal from one of Peabody Coal's mines in Colorado named 20 Mile Mine. This mine ships out 7.2 million tons of coal annually, and the coal that they ship out has a heating value of 11,200 British thermal units. This coal also has a very low sulfur and ash content, so it meets today's clean air standards. Hayden uses about 5,000 tons of coal each day. Here are some interesting stats for the Hayden plant. Hayden operates at about 30.5% efficiency. Hayden produces 446 megawatts of power per year. This equates to 51 kilowatts per hour. It takes approximately 174,012,000 BTUs per hour to run this plant. Hayden goes through 5,000 tons of coal per day, or approximately 208 tons of coal per hour. This chart illustrates the amount of efficiency at Hayden versus the amount of energy lost in heat. Primary energy usage is the process in which one energy source is utilized to create another energy source. One of these would be electricity. Oftentimes, electricity is produced by burning fossil fuels, heating water using radioactive chemical reactions, or turning a turbine with falling water. There is always a certain amount of energy used and a certain amount of energy produced. In all cases, there is a loss of energy which is converted to heat in most cases. Most new technologies in coal-fired power plants have to do with cleaner burning of the coal to meet more strict regulations of air quality. One of these new technologies is CCS, or carbon capture and sequestration. This process includes making hydrogen from water and then burying the resulting carbon dioxide and burning off the hydrogen. Some of the drawbacks are that this is very expensive still, and there's a 20% energy penalty involved in this type of clean coal process. Problem 1. If 80 BTUs of heat energy are added to 2 pounds of water at 40 degrees Fahrenheit, what will be the final temperature of the water? 1 BTU raises 1 pound of water 1 degree Fahrenheit. Therefore, 80 BTUs will raise 2 pounds of water 40 degrees Fahrenheit. We get this by dividing 80 by 2. If we take the initial 40 degrees of the water and add the resulting 40 degrees of water temperature increase, our resulting final water temperature is 80 degrees Fahrenheit. Problem 2. A coal-fired power plant has an efficiency of 38%. The temperature of the steam leaving the boiler is 550 degrees Celsius. What percentage of the maximum possible efficiency does this plant obtain, assuming the low temperature is 20 degrees Celsius? For this problem, we need to know how to convert degrees of Celsius into Kelvin, and we do this by adding 273 to the degrees of Celsius. Maximum efficiency is obtained by taking temperature 2 minus temperature 1 divided by temperature 2. In this case, temperature 2 minus temperature 1 is 550 degrees Celsius minus 20 degrees Celsius, or 530 degrees Celsius. Temperature 2 in Kelvin is 550 degrees plus 273, or 823 degrees Kelvin. Maximum efficiency is obtained by dividing 530 by 823, and we get 64.4%. The maximum efficiency obtained by this plant we get by dividing its efficiency of 38 by the maximum efficiency of 64.4, and our resulting efficiency is 59%. Problem 3. For a gasification project being planned, 26,000 tons of coal per day will be used to produce 250 million cubic feet per day of natural gas. If the coal is rated at 8,700 BTUs per pound and the gas at 950 BTUs per cubic foot, what will be the efficiency of the plant? Let's review that efficiency is equal to the energy out divided by the energy in. In this case, our input is 26,000 tons of coal per day. There are 2,000 pounds in a ton, so we multiply those together. And we multiply that by the number of BTU per pound, which is 8,700. This results in 452,400,000,000 BTUs per day. Our output of 250 million cubic feet per day is multiplied by 952 BTUs per cubic foot. This result is 237,500,000,000 BTUs. Therefore, our efficiency is obtained by dividing 237,500,000,000 by 452,400,000,000, and we get our final answer of 52.5% efficient.